Alright, my apologies first of all for anyone who has to deal with this, because this is pretty hard. The book does a very poor job of explaining this, and it is explained in the examples, the very last example, and this is precisely the type of thing a math teacher would use to torture his students to find out whether or not they understand just about everything. So example 10, and this is on page 344. If you look at example 10, it's the same kind of thing, and it tells you what you're supposed to do. It all is based on the following logic. If you take arithmetic sequence, take this one. Okay, you see the sequence, obviously we're climbing by 3. If you take any 3 of them, let's take these 3 here, you go 15 plus 21, I'm taking the first term and the last term divided by 2, and it should equal the middle term, 18. So 15 plus 21 is 36, divided by 2 is 18. We could take any 3 of them and do that. 9 plus 15 over 2, so 9 plus 15 is 24, divided by 2 is indeed 12, which is the middle term. So because we know this logic, or you have to understand this logic, that you can do that in question 18, where the sequence is given as x minus 3, x squared over 25 plus 9, and 3x minus 11, and they want you to calculate the fourth term, or figure out what the fourth term is. So to do that, we follow the same logic as this up here, and we say that x minus 3 plus 3x minus 11, I'll put those in brackets so we can maintain our plus and minus. So that one plus that one divided by 2 should equal the middle one here, x squared over 25 plus 9. And if we try to reduce that and solve for x, we can plug x into this formula, figure out what these are as numbers, and then calculate the fourth term. So it's a multi-step project where we have to first apply the logic so that we can solve for x. Once we've solved for x, we plug x into the formulas here to determine what these numbers actually are, and then we've calculated d once we've done that, and then we can figure out the fourth term. So to simplify this, to go through this, pause the video now, try this on your own, and if you get to the same thing I do, then you're in business. We'll pick it up with the next step, which is to plug the numbers in. So if you've paused the video and you've now resumed it, hopefully, and come up with the following answer, x minus 3 plus 3x minus 11 over 2 equals that stuff, x squared over 25 plus 9. So that is 4x minus 14 over 2, which is also known as 2x minus 7, equals x squared over 25 plus 9. So 0 equals x squared over 25. I'm collecting terms here. Minus 2x plus 16. If I multiply the whole thing through by 25, I've got x squared, it's still 0 on that side, minus 50x plus 400 plus 800? About 400. And this factors, that's 10 times 40, 10 and 40 add up to 50, so x minus 40 times x minus 50, x minus 10. And that means we have two x values, x equals 40 or x equals 10. And with that, let's just slide that over here a little bit. If x equals 40 and x equals 10, I'll put that up here a little bit. That means that we've got two possible solutions. So what I'll do is I'll plug 10 into this, and 10 minus 3 is 7. 10 squared over 25 is 100 over 25, which is 4. 4 plus 9, sorry, is 13. And 10 times 3 is 30, minus 11 is 19. And we can see here that 7, we've added 6, so we'll add 6 again, and 25 will be our solution. That's the fourth term. Or we can plug 40 in, because 40 was a possible solution. So 40 minus 3 is 37. 40 squared over 25, that'll take me a second. 40 squared is 1600 divided by 25 is 64. 64 plus 7, oh sorry, 64 plus 9 is 73. And 40 times 3 is 120, minus 11 is 109. And so what have we done here? It looks like we've added 36. We've added 36. So we have to add 36 again, and that would be 145. So we have two solutions because we're dealing with a quadratic. But by plugging those values in for x, we end up with two possible answers for the fourth term, depending on what the first term was and depending on what d was. Both of them work for this particular set of problems. Next video will show you number 19.